A perfect square trinomial is one that can be factored into a binomial squared. What we're being asked to do here is to find the constant value that's going to create that perfect square trinomial or complete the square. And then we'll factor this perfect square trinomial into a binomial times itself or a binomial squared. Let's give this constant a name, the constant that completes the square and creates a perfect square trinomial. In order to be able to refer to it, let's just call it the magic number. And this number can be obtained using a formula. We're going to take the b coefficient, divide that by 2, and then square that quantity. And as a reminder, the b coefficient is the coefficient on the x to the first power term. So we're looking at this value here. So in this particular case, our magic number is going to be determined by taking our b coefficient, which is -20. We're going to divide that value by 2 and then square the quantity. So we've got -10 inside the parentheses, quantity squared, gives us +100. This is our magic number that completes the square, so we'll pop it right here. And then we want to write this perfect square trinomial that we just created in its factored form. So this trinomial factors into x minus 10 times x minus 10, which is the same thing as x minus 10 quantity squared. Let's practice that again. In order to determine the constant that completes the square, again, we're calling that a magic number here, and that's going to be the number that completes this perfect square trinomial. To find that quantity, we're going to take our b coefficient, which is the coefficient on the x to the first power term. We're going to divide that by 2 and then square the quantity. 16 divided by 2 is 8. 8 squared is 64. So this is the value that we add in here to create the perfect square trinomial. Now, since it's a perfect square trinomial, we know that it's going to factor perfectly into a binomial squared. And instead of writing it as a binomial times itself like we did last time, let's just skip to the binomial squared bit. And this trinomial is going to factor into x plus 8 quantity squared. We're looking for two factors of 64 that add to 16, and that would be 8 and 8. Now, before we move on to C and D, let's notice that this number that our perfect square trinomial factored into matches the quantity that we got before we squared it when we were calculating that magic number. Notice here again, the number in our factorization is essentially the square root of the magic number. That's going to help us in part C and part D because we're going to end up with fractions in these perfect square trinomials, and those are going to be a little bit trickier to factor. So again, we're looking for the magic number that completes the square. The formula used to calculate the magic number is that we're going to take the b coefficient, divide it by 2, and then square that quantity. In this case, our b coefficient is +3, so we have 3 divided by 2, and then we're going to square that quantity. Since we can distribute a square over divide, we're basically going to square the top and square the bottom, so this gives us 9/4. And 9/4 is the constant value that is going to complete the square. Now we're being tasked with factoring it or writing it in its factored form, and as I mentioned, it is a little trickier to factor when we have fractions involved. And this is where we're grateful for the pattern that I pointed out a moment ago. A perfect square trinomial is always going to factor using the pattern where the first term is going to be x. Our leading coefficient here was +1, and so the first term of each of these binomials is going to be x. The sign in here is going to match the sign that we had in our trinomial. This one is always going to be positive because we do need the signs in the two binomials that we are factoring into to be the same, and that's what this plus sign tells us, is that the signs inside the binomials are the same, and this one tells us what they are, so they're the same and positive. So the sign inside here is going to be positive, and now the value that is in this factorization for our binomial squared is always going to match what we obtained when we originally divided b by 2, or essentially the square root of the magic number. So this is our factorization. Let's see that one last time. Again, the formula for calculating the magic number is b divided by 2 quantity squared. Our b coefficient in this case is -9. So we're going to take -9 divided by 2 and then square that quantity. We can distribute a square over divide, so this becomes negative 9 squared over 2 squared, which is 81 over 4. 81 over 4 is this magic number that we would add into the trinomial to complete the square or to create a perfect square trinomial. And there's a pattern for the factorization of the perfect square trinomial, which is that the first term is x, the sign is going to match what is inside the trinomial. Remember, this one just tells us that the two signs in the binomial are the same, and this one tells us that they are the same and negative. And now the constant value that's inside the binomial squared is going to match what we originally had when we took the b coefficient and divided it by 2. So in this case, it's negative 9 halves, so we have that minus 9 halves in the factorization. Essentially, it is the square root of the magic number, and this is the factorization of this perfect square trinomial.